Here are a couple more examples of completing the square. So let me start with the example here on the left. Remember, with completing the square, the first thing we're going to do is make sure that the coefficient of x squared is 1, and in this case it already is. The next thing I'm going to check is this a square to begin with? That is it a binomial squared? So is the constant term on the end exactly half of the middle coefficient squared? If it's not, then it's not a perfect square, and if it is a perfect square. So this is not. So first thing I'm going to do is move the 17/4 over to the other side of the equation by adding 17/4 to both sides of the equation. This then gives me the following: x squared minus x is equal to 17/4. And I'm going to leave a little bit of space here. And that little bit of space I left is so that I can complete the square. The middle coefficient here is -1, so I'm going to add to both sides half. Half of 1 is 1/2. So here's half of the middle term squared. Okay, add that to both sides. Add half the middle term squared. So what I've done here on the left side is created this situation where you have the binomial x minus 1/2 squared is equal to, on the right side, whatever this comes out to. So let me go ahead and see if I can simplify this. -1/2 squared is positive 1/4. I can add these two guys together to get 18/4, and then reduce that to 9/2, so that in the next step, when I take the square root of both sides, let me rewrite the square here, and the 9/2 with a little bit of space, so that when I take the square root of both sides, I have enough space for the square root and for the plus and minus. Don't forget that when you're solving a quadratic equation. So on the left, the quantity squared that I just took the root of gives me the quantity itself, so x minus 1/2 equals plus and minus. The root over here, you can call this the root of 9 over the root of 2. Okay. That was one of our root properties. So this would be equivalent to plus and minus 3 over the square root of 2. And in many math classes, the instructors like you to rationalize the denominator. The square root of 2 is irrational. So to rationalize, I'm going to multiply the top and the bottom of this by root 2. Root 2. And what that gives me then is plus and minus 3 times the square root of 2 on the top, and root 2 times root 2 is just 2 on the bottom. So one more step to solve this equation. I am going to add 1/2 to both sides so that I finally get x by itself. Adding that way over here. Okay. And my final solutions are x equals 1/2, that's from this one over here, plus or minus 3 root 2 over 2. And that's it. This could also be written as a single fraction. So it could have been written as 1 plus or minus 3 root 2 all over 2, since we already have a common denominator of 2. Okay, so that's this guy. And let me go on to the next equation we have here. I'm kind of bleeding over into this side, so hopefully I don't take up too much space. So here's another case where we're trying to complete the square. The leading coefficient is not 1. We need to make it 1. So let's start by dividing everything by 18. Okay, you got to do that to both sides of the equation. These guys cancel, and we get x squared plus, I'm going to go ahead and reduce the 12 over 18, reduce the top and the bottom by 6. So that gives me 2/3 x plus 29 is a prime number, so that's just 29 over 18 equals 0 divided by anything is 0. Now we're going to ask ourselves the question, is this constant term exactly half of 2/3 squared? The answer is no. So we're going to move that to the other side, subtract the 29/18 from both sides. And that leaves us with x squared plus 2/3 x. I'm going to leave a little space, equals on this side negative 29/18. And with that little space, I'm going to add half of this middle term squared. And so that looks like this, plus 1/2 times 2/3, there's half of the 2/3 squared, plus, same thing on the other side, half of the 2/3 squared. And you'll notice that we have some cancellation here. These 2's cancel likewise over here. So half of 2/3 ends up being 1/3, which means my binomial becomes x plus 1/3 quantity squared. And this is a plus right here because our middle term had a plus. On the other one, notice that our binomial had a minus here because the middle term had a minus. Okay, back to this. Equals. Let's see what this comes out to. Negative 29 over 18 plus 1/3 squared gives me 1/9. Okay, I'm going to get a common denominator here by multiplying the top and the bottom by 2 so that I can combine these guys. This would give me negative 29 plus 2 over 18, the common denominator. Negative 29 plus 2 is negative 27. That's over 18, and I can reduce that to negative 3/2, reducing both the top and the bottom by 9. So now I've got on the left side something that I'm going to take the square root of. I'm also going to take the square root of the negative 3/2. So let me go ahead and just write that root right away. Taking the root of x plus 1/3 quantity squared equal to plus and minus the root of negative 3/2. There we go. And let me go ahead and simplify this as well while I'm here. First of all, notice that we have a negative under the root, which comes out to something imaginary. It's not real. So at this point, you could say there are no real solutions to this equation, and that's true. But there are complex solutions. So let's go ahead and see if we can find those complex solutions. So I'm going to call this plus and minus the root of negative 3 over the root of 2. This becomes then plus and minus I root 3. When you take the root of that negative 1, think of this as negative 1 times 3. The root of negative 1 is defined as the imaginary unit I. Okay. Over root 2, but we are also going to rationalize the denominator here by multiplying by root 2 over root 2. I'm really just multiplying by 1, but it's a special 1, so that these things come out rational on the bottom. So this gives me plus and minus I. Root 3 times root 2 is root 6 over root 2 times root 2 is just 2. And remember, this 6 does not reduce with this 2 because it's not 6 over 2, it's root of 6 over 2. So far, I've got x plus 1/3 on the left side is equal to plus and minus I root 6 over 2 on the right side. The last thing I need to do is subtract the 1/3 from both sides of this equation. Whoops. There we go. Subtract 1/3, subtract 1/3. I always write it off way out to the side because I'm not quite sure where to put it there. But in the end, our solutions are thus. X is equal to, here's my negative 1/3 on the right side, plus or minus I root 6 over 2. I times root 6 over 2. And there we go. Again, these are complex solutions of the form a plus bi. Okay, stay tuned for a couple more examples of completing the square.